A lightning spark can make X-rays before it makes thunder. That sounds impossible. X-rays belong in hospitals. Thunder belongs in storms. But sensitive detectors near lightning have caught tiny X-ray flashes. They appear during the spark's first violent steps. So how can a thin, crooked line in the sky make radiation powerful enough to pass through objects? Start with the wrong picture of lightning. It is not one giant electric spark that suddenly connects cloud to ground. First, a faint path probes through the air and jumps. Each jump is called a step. At the tip of each step, electricity crowds into a very small space. That creates an enormous electric push. Normally, air blocks electric charge from moving freely. But a few loose electrons are already drifting around. Cosmic rays can help make them. Near the lightning tip, the electric push grabs those electrons. It hurls them forward. They crash into air molecules at extreme speed. When they slam on the brakes, they release a tiny burst of X-ray light. Now comes the strange part. That X-ray burst can knock more electrons loose from nearby air. The electric field grabs those new electrons too. They race forward and make more X-rays. One burst helps create the next burst. It is a feedback loop. Like one falling domino creating two more falling dominoes, the first fast electrons can multiply the action around the lightning tip. Scientists call these unusually fast particles runaway electrons. They are not escaping the storm. They are escaping the air's usual braking effect. For a brief moment, the electric field accelerates them faster than air can slow them down. That is why an ordinary-looking spark can produce extraordinary radiation. The X-rays do not need a giant machine. They need a tiny zone with a gigantic electric push. And this happens before the lightning channel becomes the bright, roaring thing we notice. Then the main channel heats the air brutally fast. The air expands like a sudden explosion. That expanding pressure wave becomes thunder. If this made the storm feel less ordinary, subscribe for more hidden physics and familiar things. There is one important detail. You usually hear thunder after seeing lightning because sound travels slowly. But these X-rays are often made early in the lightning process too, before the biggest hot channel forms. So the order is not just a trick of your ears. First, a stepping spark builds a tiny electron avalanche. Then the brighter channel heats the air and makes thunder. Lightning is not only a flash you can see and a boom you can hear. For a split second, it can also be a natural X-ray machine, hidden inside a storm cloud.